In this example of a law of sines, we're going to do a word problem. So this word problem is, we don't have a picture, so we'll have to create a picture to it, but it's a 95-foot flagpole that is on top of a building. It says, how tall is the building if the angle of elevation to the top of the flagpole is 35 degrees and to the bottom of the flagpole is 26 degrees. So, situation is, we have a building. All right, and then there's a flagpole sitting on top of it. And we are sitting at some point away from it. We have no idea how far. It talks nothing about that at all. Somehow, we know that the flagpole is 95 feet tall, and the angle of elevation is 35 degrees. So that angle is 35 degrees. So if we kind of go across here, we have the height of the building. We're going to cut it right down the middle from the flagpole. We know that this angle right here is 35 degrees. Okay, but then they give us a second piece of information. The angle of elevation to the bottom of the flagpole is is 26 degrees. So this one is 26 degrees. Okay, so what we're kind of really focusing on, we just don't have the right information, is if you draw this picture with the height of the building, here's where we sit right now. So if you do this triangle that has the 26-degree angle and this is the height of the building, that's all we know. So we don't know how far out we are from the middle of the building. We don't know how far this distance is from our point of eye to the bottom of the flagpole. However, if we use this top triangle and just the top triangle, here's actually where we sit. So we have this. And we know that this value is 95, and this gap, this angle, is the difference between 35 degrees and 26 degrees, which is 9 degrees. Is there anything else that we know? Yes. Because if you go back to the overall big triangle, that if this is a right triangle and this angle is 35, this angle is 35, and this makes a right triangle, this angle right there is going to be 90 degrees, or 180 minus 90 minus 35, which puts it at 55 degrees. So that little top angle is 55 degrees, which is perfect. It's really all we needed, because you can use law of sines now. You have an angle and you have a side across from it. That is totally a law of sines problem. So also good news is we can figure out this piece because that piece is the same as that piece. So we're going to do law of sines to figure out this. So if we set that up, we're going to have sine of 9 degrees over 95. Make that a little smaller. And then that's going to be equal to sine of 55 degrees over x. And that x is going to give us the hypotenuse on this right triangle. So if we cross multiply, we got x times sine of 9 equals 95 times sine of 55. Divide by sine of 9 degrees. And that gets our x to be about 497.5. So I now have this value as 497.5, and now I can use just some basic right triangle trig to kind of solve the rest. So we're looking at sine. So sine of 26 degrees is going to equal my opposite over the hypotenuse. And then multiply this piece over, clear out the fraction. So that'll go away. And then that's just something that we type into the calculator. And so that gives us about 218.1 feet. Okay, so now that we have law of sines, you have these multiple triangles that overlap each other. You have you have definitely more information than you realize in just kind of the basic right triangles. And if we needed this angle, if that was 26, we could definitely figure out that angle, but we didn't end up needing it. So that was law of sines and a word problem.